Any story problem you see is going to be our 8.2 learning target, where basically we're saying we're solving real-world applications using vectors. Okay? So in other words, story problems with vectors in it. Okay? If it's just numerical problems with vectors, that's not really 8.2. That'll fall into the 8.1 category. We kind of talked about the difference in the two learning targets last time. Okay? So I'm going to do just an example with you because there's really nothing new to teach because we've talked about resultants. All right? It's just now we're starting to put it into more of a complicated story problem. All right? And I'm going to give you two methods to do it. All right? My personal way that I usually do them when there's just two vectors is I make a triangle, I figure out the missing side, I figure out the missing direction. If I'm using law of cosines or sines, I like using triangles to do it. I'm also going to show you the component method, where you just get x and y's and then you add the x's and y's together. Okay? I'm usually more of a visual person, so I like the triangle because I can see what would be happening then and make sure my answer makes sense. All right? So I'll show you the two methods. Here's our situation. Okay? There is a 42 kilometer per hour wind blowing towards 215 degrees. Okay? So if you're thinking about that, 215 degrees would be down in the third quadrant, right? Okay? 1, 2, 3. So we got a wind blowing that direction. So south of west a little bit. Okay? And then you have an airplane that's headed towards 125 degrees at 152 kilometers per hour. All right? So the airplane sets up to go in a direction of 125, but there's a wind. All right? There's a wind that's blowing in the direction of 215. What does the resultant velocity and direction of this airplane? Okay? So, here first is going to be the way I would approach this problem. There's two vectors, right? There's going to be two forces. You got what the airplane's trying to do, what the wind's doing to the airplane, and then you'll have your resultant making your triangle. Okay? So, I'm going to draw a picture. First of all, I'm going to draw the plane first. Doesn't matter. But the plane is going to go towards 125 degrees. So I'm going to draw an XY axis here. Okay. My plane is going in the direction of 125 degrees, all right, at 152 kilometers per hour. So I'm going to draw a fairly long vector here. That is 152 kilometers per hour. Okay. And this angle right here was 125 degrees. You guys agree with that? So, the airplane, here's your airplane, okay, it's trying to do this. Okay, it set its course, that's the course that it's trying to travel. Okay, focus on this, guys, okay? This is what the airplane's trying to do. While the airplane's trying to do that, there's also a wind blowing the airplane. Okay, so then what I do is I kind of draw a new X and Y axis up there, and from that point I'm going to draw what the wind is doing. The wind is blowing at, what was it, 42 kilometers per hour at what direction? 215. So 215 is going to be headed down this way, right? Okay, so I'm going to draw an arrow down this direction. Obviously, I like drawing it to scale somewhat, okay? If this is 152, then your 42 kilometers per hour one, that arrow should be a little bit shorter, all right? The more you draw it somewhat to scale, the more sense your answer would make in the end, okay? So, here's what the airplane's trying to do. Here's what the wind is doing at that same time. So then, this is your resultant. Okay? that's what the airplane's actually going to end up doing. That is the path that the airplane will actually end up taking. Okay? Does that make sense visually? All right? So now your job is to simply figure out the velocity of that airplane, which would just require you to figure out how long that red arrow is. Okay? And then also figure out the direction that that red arrow is headed. So roughly I'd say that that airplane right here is going to be, probably in the 140 to 150 degree ballpark. Does that make sense? Rough estimate. Okay? Because we know it's 125 to here. Alright? So I just need to figure out how long that red arrow is, and I need to figure out at what direction that red arrow is headed. Okay? A couple little things here. You need to figure, we got a triangle. We got two sides. We need to know the third side. Okay? It's not a right triangle. Okay? At least I don't believe. We'll see. Okay? This angle right here was 35.
Yeah.
Right?
Yes.
Wait, why did you say that?
Well, if this is 125 and this is 90, then there's 35 more degrees right there. Okay? So if that's 35, then wouldn't this angle right there, just that little part right there, have to be 35 as well? Alternate interior.
Oh yeah.
Okay?
And then you could take.
And then this was 15? Okay? So that means this part right here had to be 35. Oh, you guys are going to luck out here.
Yes.
That's 35 right here. So then that would leave 55 right here.
Wait, how's it?
Wait, what?
Should you take 2 steps?
So this right here was 35. So that means this right here would have to be 55, because those two together would have to add up to 90. You guys see that?
Yeah.
And we already said this one was 35 here, so you actually did luck out. What do you got there?
How do we know?
But you didn't know that.
Ask
How
questions.
you know?
Or he knew that.
I figured it out, never mind.
Sure.
Yes.
Okay.
John, ask a question. Oh, no, that's the one.
So I was able to figure out that this actually ends up being a 90-degree angle in there. Okay? This was 35, so that had to be 35. This was 35, so this had to be 55. Okay? So,
Just because the 35, because of the altitude.
if this is 35 here, this has to be 35 here because of alternate interior. Is that the only 35 you had a question about? Okay. So everybody would agree this is 90 degrees up here, right?
Yep.
Okay? Now, I'm going to solve this one the rest of the way as if it wasn't 90, as if it was 89 or 72 or anything like that.
But it's not.
Okay? I know. You could use SOHCAHTOA here. You could. Most of them you won't. Okay? So,
This whole problem's a lie.
I know this is, I know this side, I know this side, I know the angle between. Don't I want to figure out this side?
Yes.
So I could use what law?
Law of cosines.
Law of cosines.
Oh, yes.
Actually, no, we do have a question on that.
It was 215 all the way to here.
Yeah.
It's 180 to here. So that leaves 35 more right there.
But the other side,
Well, how far is it from here to here? How many degrees is it?
90.
90, right? So if that's 35, that has to be 55.
Yeah.
And we already said that was 35. So would this 35 and that 55 add together to make 90?
Oh. But, yeah.
Okay? So I'm going to call this C. So C squared equals 42 squared plus 152 squared minus 2 times 42 times 152 times the cosine of 90. Yes? No?
Maybe so.
Okay?
If we didn't know that angle, if we did know that angle, we would.
You will be able to figure out that angle similar to how I just did it.
Okay.
You got to use alternate interior and that sort of stuff.
Okay.
Okay? So, do a little work here. 42 squared plus 152 squared minus all that. Square root that answer. $157.6959099.
Okay, so I have a
That's what I
question.
got.
Okay? Yeah.
I don't know if there are answers now, but the 35 on the left side of like the second grid, or the second coordinate.
Come up here and point to it.
The one next to 42. Let's put it that way. The 35.
This angle right here.
How come that's, why is that 35?
How far was it from 0 to the wind?
Okay.
215.
Alright.
So if that was 215 to there, it's 180 to there. 180 plus how much equals 215? 35. Okay? So now I know this side. If I can figure out this angle, then I'll know the angle at which the resultant is headed. Because let's say this is like 10 degrees. Then 125 plus 10 would make 135, so that would tell me that my red arrow, my resultant, my actual path of the airplane is going at 135 degrees.
You can use the law of cosines again.
You could use law of cosines again. I'm going to use law of sines instead. Because I know this side, I don't know that angle. I know this side, I know that angle. So I'm going to use law of sines. So I'm going to say sine of 90 over this, so 157.69, all of that. I'm going to use that whole decimal answer. Would equal sine of, I'll just call it A right down here, sine of A over 42. Everybody see that? Sine of 90 over the resultant equals sine of A over 42. And then get out your calculator again. 42 sine of 90 divided by my previous answer. Inverse sine that answer. I get about 15.44. Alright? So now, I can write my 15.44, yep? No? Okay. Now I can write my final answer. What is the plane's resultant velocity? Let's go to the nearest hundredth. How fast did the plane actually end up traveling?
157.6.
It'd be 157.7.
157.70.